I have always been interested in how things work. I used to take things apart to see what made them tick, but I wasn't so good at putting them back together again. But I think most children are like that. They ask how things do what they do, and why. I am still looking, but I have helped find some of the answers. In this film, I would like to share with you the story of how science has unraveled the greatest mystery of the universe: its creation. Our universe is a vast and splendid place. Our planet, the Earth, circles one of 100 billion stars in our galaxy. And our galaxy is just one of 100 billion galaxies. This great space is our home. Yet 14 billion years ago, none of this existed. There were no planets, no stars, and no galaxies. So, how did the universe begin? How did we get from nothing to all the astonishing and beautiful phenomena we now observe?
Since earliest times, there has been a passionate debate about the origin of the universe. Most religions claimed that the universe was very young. For a long time, Christians believed that it was just 6,000 years old. As fossils and other evidence began to emerge showing how much older planet Earth was, this no longer seemed credible. Estimates for the age of the universe as a whole must go much further back in time, though no one was sure exactly how far back. It seemed to make more sense, therefore, to suppose that the universe had always existed.
By the early 1900s, most scientists assumed this to be true. What's more, they believed this eternal universe had always been much the same as it is now. It was static and infinitely big. According to this conventional view, there was no beginning, and nothing very exciting ever happened.
All this, though, was turned on its head by one of the most astonishing discoveries of the 20th century. In the late 1920s, the American astronomer Edwin Hubble made a series of observations that startled the world.
My colleague, Neil Turek, tells the story.
What Hubble did was to use the most powerful telescope in the world at that time, the Mount Wilson telescope, to make a very careful study of galaxies and stars. What Hubble found is that all the galaxies around us are moving away, and as you go further from us, they're moving faster and faster away from us.
The discovery came as a huge surprise. The universe wasn't static at all. It turned out that all the galaxies in space were steadily moving apart from each other. This would be a crucial clue as to how the universe began.
Here we have a model of the universe in which every star represents either a particle or a galaxy, and the universe starts out very small and then it expands. And what you can see is that as it expands, every star moves, or every galaxy moves away from every other galaxy. So there's no center of the expansion, it's just that everyone is moving away from everyone else.
This astonishing discovery shook the foundations of cosmology. If the universe had always been expanding and you traced its progress back in time, then the early universe had started very small. The universe may even have had a beginning, a moment of creation. Despite Hubble's discovery, nearly all scientists ignored the question of what had happened at the beginning of the universe. The problem seemed too difficult to tackle. But after World War II, a small group of nuclear physicists began to take the idea seriously and tried to imagine the conditions at the beginning of the expansion. The man who led this quest was the Russian exile, George Gamow.
He was a nuclear physicist, well known for his imaginative ideas, wonderful insight, but never got a calculation right in his life, as far as I know. And he came up with the wonderful idea that the early universe might have been very hot.
Gamow considered the possibility that the early universe closely resembled an exploding atomic bomb. It was very hot and very dense. As the universe expanded, it would cool and create the basic elements of nature, such as hydrogen and helium. But his theory wasn't taken very seriously. His opponents dubbed it the Big Bang Theory. But Gamow and his colleagues made a remarkable prediction. They claimed a remnant from the hot Big Bang, in the form of microwave radiation, should still be around today. It wouldn't be strong enough to defrost a pizza, but it would be all around us. At the time, no one thought the radiation could be detected, so the idea remained just an idea. But later, it would return in triumph.
I became interested in the Big Bang Theory shortly after I came to Cambridge in the early 1960s. At that time, many scientists were still instinctively opposed to the idea that the universe had a beginning. They felt that a point of creation would be a place where the laws of science broke down, and one had to appeal to religion and the hand of God to determine how the universe would start off. They therefore looked for alternative explanations,